Unit 12 is all about systems of equations, and so for the first section we need to do some review on how to graph equations in slope-intercept form. Also, please make sure that the sub has passed out your standards paper for this unit and that you've got that taped into your notebooks. If she hasn't done that yet, please kindly remind her that that needed to be done today. So it's a quarter or half sheet of paper that gets taped in before you start the notes today. So our standard for today for this unit is all about systems of equations and understanding the solution to a system. So again, before we really can dive into that, we need to review about linear equations and graphing them. So remember that a linear equation is just an equation whose graph is a straight line. And the example here is y equals 2x plus 5. You'll remember hopefully from Unit 7 that that equation is in slope-intercept form. We call it slope-intercept form because you get two pieces of information out of it. You get the slope, the m, which remember is the number in front of x, and then you also get the y-intercept that they label it with a b when they write the general form here. So the b is the y-intercept. Again, the y-intercept is where the line crosses the y-axis. Make sure you've got these definitions in your notes. So for the first few examples, we just want to identify the slope and the y-intercept from each equation. So for number 1, remember the slope is the number in front of the x. So here it's a 4. And the y-intercept, or the b, is 7. You might see me label b, or you might see me use y-int like this. I think that's actually what's on your homework. So either one, they both represent the y-intercept. For number 2, the slope, again the number in front of the x, so the slope is 1/4. And your y-intercept, or your b, is -5. Remember, you want to take the sign with it, so the subtraction sign makes that 5 negative, so we want to make sure that we say -5. Number 3, we have y equals -2/3 x, so our slope here is -2/3. It's the number in front of the x. You might notice here that there's no y-intercept. So when there's no number in the back or no constant term, you say that the y-intercept is just 0. Number 4, we have y equals 10. You'll notice the equation number 4 does not have an x term. So because there is no x, we say that the slope is 0. And then the y-intercept here, which I'll label again as b, the y-intercept is 10. So you'll notice number 3 had no y-intercept, so b was 0. Number 4 has no slope, so m is 0. Next we're going to look at 5 and 6, and these are a little different because they aren't already in slope-intercept form. So the first thing you have to do first is put it in slope-intercept form. And remember that's y equals mx plus b. So when we have something in slope-intercept form, we have the y by itself with no coefficient in front of it. We have on the other side, the right side of the equal sign, we have the x term followed by our constant, which is our y-intercept. So for number 5, we need to get the x term on the other side. You'll always move the x term first, and we're moving it to the other side of the equal sign. We're subtracting 2x because it's positive 2x. So those cancel out. We bring down the y and we bring down the equal sign. Next, we cannot combine these. You can't say -3 minus 2 because it's actually minus 2x. We like to put the x term in front of the constant. So we're going to write y equals -2x minus 3. So now when we state the slope, we get -2, and when we state the y-intercept, it's -3. So if you look back at the original equation, you'll notice that the 2x was positive over here, and students oftentimes want to say that the slope is 2. But what you're forgetting is that that term needs to be on the other side of the equation. So moving it to the other side actually changes its sign, which is now why it's negative. And number 6 is even a little bit trickier. So we have -4x minus 2y equals 8. So again, we still want to get the x term on the other side. This time we're going to be adding 4x because it's negative. So we're adding 4x to both sides. I'm going to bring down a negative 2y. Make sure you're recognizing that subtraction sign has to come with it. And it's going to equal 4x plus 8. Again, I can't combine these two terms, and in slope-intercept form we like to have the x term first and then the y-intercept or the constant in the back. So that's why I put the 4x. That's why I say 4x plus 8 instead of 8 plus 4x. Now we need to get rid of this coefficient on the y. This is negative 2 times y. So we get rid of negative 2 through division, but you have to divide everything by negative 2. So we get y equals 4 divided by negative 2 is negative 2x, and 8 divided by negative 2 is negative 4. So negative 2x minus 4. Now our slope is negative 2, and our y-intercept is negative 4. Very different from how the original equation looked. Okay, some of you might have tried to say that the slope is negative 4 because you see a negative 4 in front of the x, but notice after we rearrange and divide, your slope is actually negative 2. So some steps for graphing in slope-intercept form. When you graph in slope-intercept form, and you do need to write these down, the first thing you have to do is rewrite the equation in slope-intercept form. Remember, that's y equals mx plus b. This is how we learn to graph equations without having to make a table of values. The second step is you're going to plot the y-intercept. Plot the y-intercept on the y-axis. And then also number 3 is then use the slope to find the next several points. And the note here that I want to point out is that your lines will need to go all the way through the graph. So don't just stop at 5 points. Make sure they go all the way through the graph. We're going to be drawing multiple lines on the same graph in the coming days and in the next few lessons. So I want to make sure that you're already in that habit. So again, your lines need to go all the way through the graph, and you'll see why that's important in another lesson. So let's make sure it's in slope-intercept form, state the slope and the y-intercept, and then we'll graph it. So this is already in slope-intercept form. That was step 1. So I'm going to go ahead and label the slope as 3. And remember that we like to write it as a fraction because we're going to do rise over run. And the y-intercept is 5. So step 2 on the previous slide was to plot the y-intercept. So we're up at 5. Our slope is positive, and I'm rising 3 and running 1. That means up 3, and we're going to go to the right 1. So from 5 on the y-intercept, I'm going up 3 over 1, and up 3 over 1. I kind of run out of room there, so I just about estimate. Now I want to go down 3 over 1, down, let's see, 1, 2, 3 over 1. That's kind of hard to see with all those numbers there. Down 3 over 1, down 3 over 1, down 3 over 1. So notice again, I went all the way through the graph, and this is what I want you doing with your lines. We're going to have multiple lines on our graphs after today's lesson, so we want to make sure that we get all the way through the graph like this. Hopefully this is pretty easy for you because we still have been practicing these on our bell works. We've had a lot of graphing and identifying slope and intercepts with bell work, so hopefully this is pretty easy for you today. Number 8, it is in slope-intercept form, so we don't have to rewrite it. But if we're going to state the slope is negative 2/3, and the y-intercept is negative 3. So we have a slope of negative 2/3 and a y-intercept of negative 3. So on our graph, we're going to go down to negative 3, that's the y-intercept, and we start there with plotting at negative 3. And now we're going to use our slope. We're rising 2, we're running 3. So that means we're going up 2 over 3, and we want to go in the negative direction. So we're going to go up 2, but this time I'm going to go to the left, up 2 and to the left, up 2 and to the left. Again, we want to go all the way through the graph, so I need to go down 2 to the right, down 2 to the 1, 2, 1, 2, 3, down 2 and right 3, down 2 and right 3. So now I am all the way through this graph, which is what we want to be. Cool. All right, number 9, we have 4x plus y equals -3. So here we are not in slope-intercept form. We need to get in slope-intercept form first. We do that by moving the x term. So we're going to subtract 4x to the other side. That's y equals -4x minus 3. So now when we state our slope, -4, and our y-intercept, -3, we're going to start down at 3. And remember, you can write slope like a fraction, so you can see rise over run. We're going to go up 4 over 1, up 4 over 1. Notice we're going in the negative direction. We want our line to have negative slope. Okay, I just kind of estimated that last one. Again, please make sure that you are getting these graphs into your notes. They don't have to be super fancy or have to have all of these background dots on the coordinate plane, but you should have a nice x and y axis with some dashes to indicate, you know, maybe through 10 or through 8, since you don't have graphs for these. After you finish your notes, you do need to show them to the substitute. She will give you worksheet 12-1. I should not have to say this, but my expectation today is that you are being kind and respectful towards the substitute. You should always be that way, but especially today, since I'm not there the day we come back from a break. The worksheet, if you don't finish it in class, will be homework.